Everybody, good evening. I hope all is going well. Let's have a look at where we are. So I guess from your point of view, the big thing that's happening is, I'm giving a lecture tonight, and then you're starting to present. So the technology evaluation presentations start next week. So the groups that are presenting next week need to get me those videos by whatever day I email out, I guess. I think I said the Monday. I just need a little bit of time to kind of put them together into a lecture to kind of replicate the presentations, let you view them in some coherent way altogether. Otherwise, tonight is a one topic night. I want to talk about security. And of course, this is one of those things. It's always there as you're programming. Like, security should be something at least a little bit in mind. For web development, it has to always be in your head. And this is the problem, right? Like, not that you can't write a secure line of code. That's easy. The problem is writing only secure lines of code and having this piece of code over here interact securely with that piece of code over there. Good code helps, good design helps, but you still have to be a good programmer. This study, it was great. University study, I think. Yeah. They went to freelancer.com, which I don't know how reputable a site that is, but they found some people to write some code. And they said, okay, you have to do this. You have to do this thing securely, even with the instruction of do it securely. Many people took the money and didn't. Like, long story short, and it's worth a look just to see the various ways in which contractors are willing to take money but not provide the thing that they're getting paid for, and possibly do work that is over their heads, right? Like, maybe these are people who are like, oh, I'll take the money. I don't really know what that word security means or what the specific requirements are, but I'll take the money anyway. Don't be those people. Be better than that. So, of course, this is something easy to say, right? That, oh, what you should do is exactly the right thing. There's a collection of behavior that you want the user to have. Like, you want them to be able to modify this field but not that field or whatever. So let them modify this field but not that field. Easy, super easy to say. It's also worth kind of keeping in mind, even if things aren't perfect, you can mitigate that danger. So you can't control on a website, like, a user using you can a little bit control them using a bad password. You can't control them using the same password as on another site, or emailing their password to their friend who's an idiot and posts it online or something like that. So it's possible that you have security problems that are outside of your control as a developer. And of course, the problem here is now you're the one at risk. If you create an app and you just put the app on somebody's phone and you sort of allow them to do something stupid, well, that's on their phone. And that's still not something you should do, but kind of not your problem the same way. In this world, it's your server and your database that are the things being attacked. You need to worry about it. So a couple of links here on this slide. The 25 most dangerous software errors. These are a little more general. Like, these include, like buffer overflows, things that are not web specific, I guess, but some that are. Like, I'll talk about CSRF tonight. The one the tab I'm going to keep open here is the OWASP. I forget what OWASP stands for. Open Web Something Security Project. That has this top 10 list that they've kind of updated a few times. I feel like they're kind of due for a refresh pretty soon. This is a 2017 list. I like this list. It kind of matches my experience, I guess, seeing students and others do web development and seeing the kind of things they get wrong. on the security side. So I'm going to keep that open and kind of refer back to it. Fundamentally, again, like there's this, underlying thing that you don't control your input. HTTP requests come in from who knows where with who knows what motivation, and whatever bytes can be sort of sent down the wire you might receive. So maybe this is a robustness principle, that be liberal in what you accept and conservative in what you send. So the liberal in what you accept means sort of, well, any kind of bytes that come over the wire, you're responsible for dealing with them. You would like to deal with them in sort of a constructive way, like if the input comes in, you want to deal with it. But it also means that if the input is just wrong or malicious, you should deal with that too, safely. Even just a dead simple example, like you've probably written HTML like this at some point. This is it's a select drop down, right? You have the little thing, you click and pop option 1, option 2, option 2. The user selects one of those. And of course, it's very easy to say, well, I produce this HTML. The string that I will get back from the user will be exactly one of these 3 things. But of course, if nothing else, like maybe the lesson from exercise 3 is this HTML is not the only place that the input that you get back from the user can come from. You can use curl or get or the developer tools or whatever and produce any kind of request you want with any kind of string. It's not even hard, right? Like there's the developer tools that let you find a thing and edit it on the page. So even somebody who doesn't, know the command line can modify the HTML form kind of in place and then click submit. Easy. So you don't really know. You would like the input from the user to be one of those 3 strings. You can even say, unless it's one of those three strings, I'm just going to say, no, I cannot process this request and send back some kind of, form validation error or whatever. But you don't know it's one of those 3 things until you check on the server. And I see this a lot too. And again, I think the the front-end frameworks kind of promote that. They don't promote the good spelling of the word verified. But anyway, where you can write logic in your front-end framework that makes sure the user has a good input, their password is long enough or whatever. That's fine. It's nice user input. But you have no idea if that JavaScript code is going to run. You have to check server side. That's the only place you have control and can actually guarantee that the logic runs the way you think it does. As a overall, you expect some input from the user. They're going to enter their name, or they're going to select from the drop-down box, or whatever it is. Maybe the field is missing. It's possible to just have the request come in with that field missing, or with an empty string, or not one of the choices that you expected, or like non-ASCII Unicode. This is something that certainly when I'm programming, I try to be careful of writing, like testing my code with non-ASCII characters, just making sure that Unicode characters make the transition all the way from my keyboard into the database and back again, just to make sure. Or if I don't think those are legal, I'd better check and say, you've entered in, I'm sure SFU has some rule that your name has to be made of ASCII characters or something. Hopefully, there's something on GoSFU or wherever you entered your name when you signed up to be a student that checked that. Is the length legal? Like, there's probably some limit on your database field that name can be at most n characters. You maybe should accept that people have long names and you should have that limit be pretty big. But hey, what if somebody gives you 31 characters and you can only store 30 in your database field? Does it throw an exception? Does it break something? You probably should know and check. When you're sending data out, again, you have to be conservative in what you send. So, I mean, just at the most fundamental level, if you're trying to display a less than sign in the user's browser, again, I suspect ampersand LT semicolon is the way to spell that. And you just have to make sure that that gets done. My my advice in general here, and this is true whether you're like, if you're sending HTML, if you're sending HTML, you're sending URL, or like you're building a URL or building a JSON string or whatever it is, don't do this security step yourself if you can avoid it. Okay, do you know, okay, like I've given you one. What are all the special characters that have to be escaped when you're producing HTML output? There are 5 of them. And I'm going to guess that some of you right now have about 3. The 5 are, do I have an editor here somewhere? Okay, so we know less than has to be turned into ampersand LT semicolon. Greater than, same deal, like it ends, of course, less than starts a tag, greater than ends a tag. The other one that I suspect that you might have thought of is a quote. So the quote character doesn't have to be escaped in text in HTML, but it does have to be escaped in attribute values. Probably best to do it everywhere just as part of the habit. And if you find an HTML escaping function, it'll do that. There's 2 more. And some of you are yelling at the screen this one, because of course we just noticed that the ampersand does something special. It starts a character reference. So if you want to display an ampersand, it has to be spelled that way. There's one more, and it's the single quote, which can be used to quote attribute values, or the, I guess, apostrophe, if you want to remember it that way. Those are the 5. Experience tells me that when I'm in a room and I ask this question, very few people get all 5. What are the characters that have to be escaped in a string in a SQL query? And I'm not going to tell you this one because I have no confidence that I know the answer. How do you escape a URL? Like if you want to insert this string in a URL, and the answer to that one is shockingly difficult because it depends where you are in the URL. The rules for escaping things in the path versus the query string are different. Hopefully you can have some library do it. Anyway. And by the way, like every programming language where you might be doing this, has some function for this. So, you know, you expect the user to enter some input like that, and they can, but somebody comes along and enters that kind of input. You need to produce this output, not literally that as output. Easy. Okay, so I want to go through here some specific things. So again, in general, you have to accept arbitrary output and always produce arbitrary input and always produce safe output, and you know, all of these things. There's a few things that are specific to the web that I think are worth spending some time on because they're easy traps to fall into. They are things that people do wrong specifically, and again, like this OWASP top 10 list is not completely different from what I'm going to talk about. I've seen a lot of student projects. I've seen a lot of web code. This is my list. So SQL injection is certainly less common than it was in the past. In general, code injection is, well, even like this kind of problem back here of the user types a string, like that's a perfectly legal string, and I put it into some code context. In this case, I'm imagining, oh, that's going to become HTML. So I have to create valid HTML as I do it. SQL injection is that while creating a SQL query. So it's a special case of code injection for specifically building SQL code. The way it happens is like this, right? You have the user, or you get some input from the user. And I find usually when people say input from the user, I imagine like, oh, they typed something, right? They typed an ID, but this could be just, it was part of a URL. It was selected from a drop-down box or whatever. It was part of the user's session information that you built from who knows where. but you get some value as input from somewhere. And you want to update the thing, the row in the database with ID equals that. And if this was an integer, I guess encoded as a string, that would have been perfectly legal. But you haven't, nothing in this code proves that it's an integer. You have no reason to think this contains only digits. It's just some input. This is some input. This is the one you'd notice, right? This feels like the worst case scenario. I might argue that kind of this one is even worse, that this one you would notice because everything would break because all the data's gone. This one might give an attacker access to something or allow them to change the password or whatever it is in a way that maybe you wouldn't notice if they were subtle enough about it. But of course, this code would build a perfectly valid SQL query. Give or take my SQL syntax. I think I got it right. I guess I probably had the wrong quotes there, but this is something that you might just have an attacker up, fiddling around with your database where you have no way to notice, and that's super dangerous. The reason that this is less common than it maybe was in the past, the relatively distant past by now, is most people start most projects mostly with object relational mappers and don't build SQL, right? Like in this course, you are not going to write code like this because realistically, your SQL queries are going to be built by somebody else. And it's kind of easier to solve the problem in that case because you have sort of one place where a SQL query gets assembled in the ORM, and you only have to audit one place to make sure that's done properly. If you're doing the sort of building queries all over the place through your code base, you have to check every one of them and make sure everything is escaped everywhere, and that's really hard. The sort of one step less satisfying solution is whatever database connection library you have has some kind of function like this. It's like build the query or execute the query or whatever. Here's my query template with some %s style, like places where you're going to take a value and put it there. And then here are all the values, in whatever syntax, whatever language, with the semantics being like, take this string, put it here safely. Take this, put it here safely. Escape it, put quotes around it, like whatever you have to do to put that value in a legal query string, in a legal SQL query, do that. And you probably should double check. This is one of those things that I find I do every time I'm in a new language, new tool, whatever. I compulsively double check. What if that string has a quote in it? What if that string has a semicolon in it, or whatever the illegal things are? Probably it's a quote for SQL. Does this thing escape the way I think it should? Let's check before we assume it. But then, of course, everywhere you use this function, it's safe. The worst case scenario is, like I said, where you have to write code like this. You do have to sort of build the query by hand. Those line numbers are annoying. There we go. And you do something like that, right? You say, everywhere I'm putting a string into a SQL query, I am going to escape it. That's easy to say, and it's easy to do in like n-1 cases. Somewhere in your code, there's the spot where you forgot to call that function because you were, it was 5 minutes before you wanted to run out the door or whatever, you were tired. You really don't want to do this. You want to do something like, again, find the library function that does the exact thing that you need done. And again, in whatever language you got or whatever tool it is, so there'll be something like that. Again, even better, just don't worry about SQL. Let the object relational mapper worry about SQL. So I'm going to flip over here to this injection. So again, in OWASP, it's a more general injection like category. So for every I don't know, top 10 entry here, I am kind of interested. Like I'm always intrigued by these values, and I think they have drifted over time. Um, how common is it? And again, I think this is relatively uncommon in the modern world. The tools have gotten better in general. So again, for SQL that I've been talking about, but wherever else you're building, like if you have to shell out and run some shell command and capture the output, creating that shell command is sketchy. So again, the tools have gotten better, where you often are doing this higher level thing where you're saying, I want to do this LDAP query, whatever that is, but I want to have these parameters in there. And if the tool makes it hard to do it insecurely, great. Is it easy to detect? Yeah, I think usually injection attacks are easy to find. You have some sense of, okay, I'm using SQL here, so it's a SQL injection. If it's a SQL injection, maybe a quote. So if I have a string that's wrapped in quotes, if I put a quote in my string, does that somehow break the query? If it does, then I can have quote, semicolon, or some other stuff or whatever. And then if I'm in the outside, if I'm using a website and I want to attack some kind of injection vulnerability, how hard is it to do that? It kind of depends. Of course, it depends where it is and kind of how deep, and of course whether the attacker knows exactly where to poke or if they're just kind of putting in strings to see if something breaks. Yeah. Okay, so cross-site scripting is another sometimes it's another instance of code injection, but again, specifically on the web, this is a big deal. And again, this is a little more common to see in the modern world than SQL injection, I think. It's what my gut tells me. And this is, well, the user typed some stuff, right? The user entered their name, their like bio for their profile, a comment on a blog, like whatever it is that the user gets to type. And again, you assume it's just text. It's all just text. Put the text into HTML, but they have inserted some not maybe quite plain text. Because of course, if you ask the user to enter a comment, like this is perfectly legal text, it's a string, and in some sense, there's nothing wrong with the user typing this. Maybe the user is in some discussion forum and they're talking about HTML, so they type HTML tags as an example of what to do. So what you don't want to do is take that code and just sort of do that with it. Whatever the whatever your local equivalent of that is, because then this will be interpreted by the web browser as a script element. So whatever JavaScript code the user can put in there, no matter how malicious or damaging it is, it runs. So again, this is easy. The output gets escaped. Less thans get turned into %LT semicolon and greater thans and quotes. And I noticed actually, I ran this through, I think I did this, maybe I should try this actually, since I have this open. Oh, so either I produced this code example by hand or with some other tool. Interestingly, the Python HTML.escape function does escape single quotes, but it does it as a numeric character reference, not as the apostrophe, which, fine. It's safe either way. It's a funny choice. I'm a little surprised by that one. So again, easy solution, no problem. Cross-site scripting is, of course, it's as dangerous as JavaScript code, which means potentially very dangerous. So, you know, if I can inject arbitrary JavaScript code into some web page, then I can say, well, all the links now go to my website, or all the links go through my like ad tracker bounce or whatever, or the form turns in, you know, when the user clicks this, it takes them over to my website with a change, or to some other website with a change password, or you know, any one of a million things. You can, from JavaScript code, make a request back to the originating server. So yeah, it could be get some data from the server, bring it into the page, make every link be some link from this page back to my site where that information gets passed along in the query string or whatever, and hope that some users click those links, and then I get their whatever personal information from the server I want. So this is bad news, right? Like, this is really something you don't want to happen on your site. So again, easy solution to say, make sure you escape all your output. Even easier to actually do, because probably most of your HTML is not going to be generated by hand, right? You're not actually going to be concatenating this string and the user's string and this string. You're going to be going to a templating system where you write something like, I was trying, like, is that handlebars? Or maybe, we'll do Ruby. So like, if you're in a Ruby on Rails template, you write something like that. If I can do it off the top of my head, I think, or maybe it's this. Anyway, and this syntax is, take whatever's in this variable comment, like comment was passed to the template as one of the values it needs to build itself. And the semantics here are not take the string and dump it in this spot. It's take the string, escape it safely, and put it in that spot. If you have a templating system that doesn't escape by default, choose different tools. That is a fundamentally critical mistake in a templating library if it doesn't do that. If you have to do it by hand, find the function. So again, I happen to know that in Python, this is the one that I probably want. It's been around for a while, and it's nice and safe. Once in a while, right? Like, again, most of my, like, I would say 97% of the HTML I generate is from some templating system. The other 3%, sometimes it just has to be generated in code because there's just logic that's intricate enough that something has to be put together with in some method function, method on a class that's overriding something. In that case, maybe I have to do the escaping by hand just to make sure everything's safe. And this is definitely, by the way, this is a case where I slow down. Like, my speed of writing code when I'm relying on, and I know all the defaults are safe and everything's good, suddenly changes very much if I have to actually build HTML by concatenating strings or building a SQL query. In all of those cases, I notice myself doing it, like my fingers slow down and I check everything very carefully because the default is dangerous and you should slow down in that case. So it's nice to do that. Like, it's fine and it's safe, but the problem is, like, if I take this string, so I don't know, it looks like the way I've written this, it's a user's bio. So that's a multi-line string in Python, the triple quote. So I just have a string with a couple new line characters in it. So if I escape this thing, okay, it turns into that. Fine. But if I take that and I insert that in whatever code I'm writing into HTML, then the display is this, right? Like, that's fine. And again, it's safe. That's fine. That's great. But, and this always irritates me. Some of you are going to do this on your project. If you give me a multi-line text input, a text area to enter text, and I enter multiple lines, you probably want to display them as multiple lines. It's not a huge deal to do this. In fact, it's a very small deal to do this. It's new line characters should be line breaks. Again, depending on the context, if that's actually what you want. And again, a lot of templating systems have some kind of automatic thing to do that of like, yeah, honor the line breaks here because I want the user to have that output properly. If you want a little more formatting than that, where again, if I'm letting the user enter their bio or a comment or something, I don't want them to be able to sort of inject a script element, but I want them to be able to like use strong or EM just for a little bit of formatting, or insert a link, right? They should be able to somehow create an ahref. And that's where these tools like the sort of lightweight markup languages, I guess would be the category. Things like Markdown is great at this. You've probably written some Markdown code at some point in your life. Wikipedia is going to have an example here, aren't they? Yeah. Where you, oh God, I forget I would never create a heading that way in Markdown. But anyway, you know, this kind of syntax leads to an H1, and let's see here, the underscore turns into EM, and the double star turns into strong, and that's fine. I suspect this is not news to you, but the whole idea here is the language is restricted enough that the output is reasonably safe. You can't, there's nothing I can type on the left here that will create a script element on the right. But I can create a link. I hate the Markdown link syntax so much, but anyway. Every other place you create a link, it's URL and then text. In Markdown, it's text and then URL. And talking about times when my fingers slow down and I have to think about it. So it's in some sense, the whole point of these things. They're light markup languages that are kind of easy enough for minimally technical people to produce, but they also produce safe output, probably. This is another huge irritation of mine. Safe should be the default. And I don't like, hopefully I can get the font size okay here. So this is just a live demo of the textile lightweight markup language and the HTML it produces either in code or in display. So I think I can. So yeah, all right. You know, I typed some stuff here, and it's presumably a paragraph that I just created. Yep. Okay, so the very first thing I would do in any of these tools is start trying to break them. And it looks like this is doing the safe thing, right? Like I'm getting escaped output. And the thing is, it's not only is this thing dangerous by default, it's misleadingly dangerous by default. So that is text. That, as soon as I sort of have the legal markup, it's markup. And it stops escaping the less than and greater thans in my output. That's a big surprise. Like, I don't think anybody in this context would think that this code would produce this output, that output, and this code would be legal markup. And okay, so maybe oh no, it doesn't. It did create that script element with, I didn't actually get the pop-up, but anyway, I'm confident that if I did this in the right context, like actually sending it out to the user, I would get that alert. That is a horrible, horrible default. It's fine, like in their context where you want your lightweight markup language to be a little bit more freeform like that, it absolutely should not be the default, and that horrifies me. I wonder how many sites use textile markup for the user and just didn't know. It's so easy to not check that one or to not know. So again, those tools get you, at least again in general, probably enough flexibility for most things. So, again, the comments and the bios and the even like wiki style, fundamentally that's what wiki text is doing. Like if you edit one of these pages, this wiki text that describes that page is again one of these lightweight markup languages where, I guess the double square brackets mean link to this page. That's almost always enough, but if it's not, or if you want to use something like TinyMCE, which is totally going to load eventually, but this kind of text editor, right, where you let the user have some little more like clicky draggy kind of editing, where you can do that kind of thing. I guess it's already bold. That's, again, in some contexts you want this. Like it's not always reasonable on every site to say, okay, well, type some markdown code. If you want to use one of those, the fundamental thing that this produces is HTML. So you're going to get kind of arbitrary HTML back from the user. And once again, I think it's very easy for a developer to look at this and say, oh, in TinyMCE, like you get to configure this. You get to say, should the strike through button appear or not? And you can say, well, I don't want users to produce strike through markup, so I won't let that button appear. But of course, whatever's about to happen here, like the submit button that's not visible on this page, submit, and then just that string of HTML gets sent off to the user. There's no reason to think that exactly this tool built that HTML. Maybe the user's malicious. I bet if I pop up the developer tools, I can put arbitrary stuff in there somehow. In that case, it's super tempting to want to sanitize the HTML yourself, to say, okay, I don't want this tag or this tag, so I'll go looking for those and exclude them. And let me tell you, you're going to not do that correctly. These tools like Bleach and HTML Purifier are in some ways not like, HTML Purifier sounds like it takes HTML and tidies it up. What it does is much more like a markdown processor. It's take this as input, parse it, and then take it as input and produce HTML as output, having completely rebuilt the HTML, knowing absolutely that your output is safe. So hopefully you can find such a thing for your language. Bleach is for Python. Purifier is PHP, I believe. Yeah. Again, the idea here is you as a developer can say, I'm willing to accept exactly these tags in my HTML and no other ones. Or I'm willing to accept these tags and these attributes on them. So you can say like, oh yeah, I'm willing to accept a href, but not rel or not target or something. So exactly which features of HTML do you allow your user to access, which is a big job. And I'm super glad I did not have to write this code. These are tough jobs, and they have, and these are long-standing projects that have been well tested. Great. So again, that's the solution. If we look at this in OWASP, yeah, I think this is fair. It's not like hideously common to have cross-site scripting or basically HTML or JavaScript injection. Yeah, it can be tricky to detect because it's not always clear exactly where it's going to sort of happen. There's so many places where code can get inserted into HTML. I would say it's a little. I would say it's a little easier to exploit than that. I might turn that box red, which I think is the worst color. Usually, if there is a cross-site scripting, it's pretty easy. And again, like I will promise you right now, when marking your project, my name is going to have a script element in it, and so is my bio, and so is my first comment. Absolutely, this is something that's pretty easy to test, and you should get it right. For example, like I just said there, it's kind of hard to know all the places where code can get injected into HTML, and here's one that I bet you didn't think of while I was saying all those things. If I say, well, what's your name, what's your bio, what's your homepage URL? That's a URL. It's a perfectly legal URL, right? And if I put it in a page and let the user click on this, oh, it's being disallowed. I can't actually type it in the browser. If I bothered to create an HTML page and put this link on it, it would, when I click the link, the alert would come up. So I have to somehow also sanitize my URLs and know that my URL, well, what are URLs? They're allowed to be HTTP : or HTTPS : Is that all URLs? Probably. And it's probably good to even like non-malicious things. I don't want my homepage URL to be like a mail to or a Zoom meeting or any of the other sort of schemes that you can put in there to trigger various behavior. I probably want actually a web page. The mitigation here, which again, certainly if you're starting a new project, this is something that should be done. The content security policy header it's one of those things that should never be necessary. You should never need this. It should never be a problem. But life is imperfect. So the idea here is you send, you put in your just standard, like every page that my site builds sends back this header as part of the HTTP headers, and you express things like scripts. So JavaScript is allowed to come from my site. So this is like an external .js file coming from the same server as the page, and I'm allowed to load JavaScript from apis.google.com. And if the browser honors this, and I think every modern browser does, then if somebody does manage to inject some JavaScript link on your site and to maliciousite.com, the browser will just say, oh, your content security policy says that's not allowed, and will block it. Can I use content security policy? Again, like I just shot my mouth off there and said it's supported. Okay, wait, so this is the one I'm talking about, the content security policy header. Ooh, so in IE11, okay, I don't know if you can read that, and I don't know if I can get the font size. So you can, but in IE11, you had to call it something different. You had to call it X-content security policy. In all the modern browsers, it looks fine. So you can do this. And again, so even if it doesn't get supported by every browser, at least you're helping in that worst case where you do have some kind of JavaScript injection, but you didn't notice. So there's a bunch of other stuff that can be done with content security policy. Where can fonts be loaded from? If I submit a form, so a form action equals something, and I'm going to click submit, where can it be submitted to? In particular, like, again, if something goes wrong and there's a form on my website that's like change your password, I really, really don't want that form to be submitted off to some third-party site, because it's usually going to be what's your current password and what's your new password. I really want to make sure all forms are submitted back to me, because that's how I've designed my site to work. You can also include a report URI where basically if something happens, the browser will send a request back to your server that says, hey, just so you know, your content security policy was violated over here. Where do style sheets come from? So again, this is something, it can be hard to retrofit on an existing site, because one of the things you are almost certainly going to disallow is inline scripts. So this should be just plain not allowed. Whatever this sort of JavaScript inline is a URL, should be something that you say no to. And that's something you can express with content security policy. If I can remember how, we'll find out. So yeah, okay, so you can say what site can, so again, like code is allowed to come from myself and from my content delivery network or whatever. I'm not allowed to use the eval function because that's unsafe. I'm not allowed to use inline JavaScript because I'm not going to, so if it's there, it's because of some injection. All of these things, again, they're easy to say. If you have a big existing code base, maybe you have violated some of those rules in some sloppy code somewhere. But again, starting new, I would absolutely create a nice CSP header and have it as part of my my site. And then when you're developing, okay, if some developer comes along and tries to do inline JavaScript, they'll get their hand slapped and they'll have to figure out why their thing doesn't work, but they'll fix it and they'll do it the right way, which is probably the right thing to do. Yeah, like I said, hard to retrofit that one, but all right. So insufficient auth, and by the way, the content security policy header, it's just not as common as it should be because you should never need it. It should never do anything. All of your code that you produce should be safe. It should follow the rules that you've set, and you should not have any cross-site scripting injections on your page. If you do, this can at least help. So I also understand why developers don't bother, because it doesn't sound like it's necessary. It's a mitigation. All right. Okay, I like this lecture and it's important, but it does feel like a bit of just a laundry list at some point. Anyway. Okay. Insufficient authorization. This is the thing you're going to do on your project. A quarter of the groups are going to have an insufficient authorization problem if history is any judge. So the problem here, and this is a thing that happens in life, it's very easy to sort of produce this thing on your menu page or whatever, right? Like show user X all of the orders that they've made, and they can link through and see the order details or whatever. You don't have to be a super genius to realize that if I see a URL like this, I'm going to try a URL like that. And again, 100% of the time, and I do this sometimes just out of sheer boredom. Like if I see a URL with a number in it, I just like increment the number and see what happens. What I should see, of course, if I happen to make 2 consecutive orders, then of course, fine, I should see it. What I should not see is some other user's order that, just because I guessed the URL for that information, even if, and there's a bit of a gray area here where if I have some genuinely hard to guess huge URL like that, that's hard. It's better. You know, I'm willing to say that if I looked at this URL, I have pretty good confidence that if I changed that thing to a 1, I would not find useful information there. It's still possible that, you know, somebody looks over my shoulder, sees a log in some refer header or something like that. It's just on a shared web browser, and that history kind of becomes public as a result of somebody else sitting down at that computer. Just knowing that URL is not terribly special. Again, it's better, but imperfect to make the URL really hard to guess. Again, the fix is easy conceptually. You should check. If a request comes in for a particular piece of information, as a developer, you're writing logic. You're creating your controller or view or whatever your framework calls it. Okay, when this request comes in, if somebody is requesting information about order 1, 2, 3, 4, 6, the first thing is like look up that order, see who the owner of it is, make sure that the person logged in is the owner, and then go on and do whatever. It's super easy. You just have to remember to do it all the time. That's the hard part. And like I said, this is something that some of you are going to do. You're going to write sloppy code because you're trying to get it done fast, and you're going to just assume that because the user came to that URL that they're allowed to see it. Okay, I completely disagree with OWASP on this one. Whatever the biggest number is, that should be what goes here. This is common, and it's common in real code. Usually, actually deployed systems are a little bit better checked for that, but it's certainly out there. Again, I would argue detectability. Again, maybe they have a sort of broader category here than I have in my head, but detectability is pretty easy. Okay, you maybe have to do it manually, I guess. I will admit that, but it's easy to detect manually. Again, it ends up being the result of code like this, and there's a problem with this code, and I guess you can probably guess what the problem is, but it's more, where's the fix? And by the way, people write this, again, whatever their local equivalent of this is all the time. It's, oh, I don't want to have security problems. I'm going to make sure the user's logged in, and then I'll show them the order. Being logged in, being some logged in user isn't enough. You have to be a logged in user who's actually allowed to do the thing that you're about to do. And it can be this easy, right? It's make sure the user's logged in. Yeah, in the URL there was that number 12345 or whatever. Go find that order with your object relational mapper if it's owned by the user who's currently logged in. That's the difference between an authorization problem and not. And again, I'm assuming my logic here is orders are only visible to the person who made them. You have to be logged in as you to see your orders. You can't see anyone else's, and no one else can see yours. And this is kind of the reason this isn't automatable, right? So things like the cross-site scripting, like escape your output, is kind of, the tool can help. It can say, okay, if there's a string, I will escape it by default, and that will get rid of almost all cross-site scripting problems. In order to make this work, I have to understand the logic of my site. I have to know that the rule for me is that this object, whatever it is, the sort of visibility rule is I have to know the order ID, and I have to be the owner. If both of those things, then I can see it. So it's very hard for any tool to kind of help too much with this, because I could say tomorrow, oh, you know what? I have a new rule for my site. You can see an order if you're the owner of it, or you're the manager of the organization that this person is a part of, because you've just introduced this kind of enterprisey kind of layer of logic to your site. So this might change, and the rule for who is allowed to see the thing might change, and it's kind of reflected in this code. So like I said, the thing that happened in the first code on that last slide is the person was authenticated. We knew who the user was because we checked to make sure, are they logged in? Okay, they're authenticated. I know that the person behind the keyboard here is Gigi Baker, or at least they have typed the right password to be. I didn't do the authorization check, which is to make sure the person is actually allowed to see the record. Again, this is the thing that seems all too common when people are writing code just a little too fast. This does have to be kind of checked by hand, because I think in general, at least, you need some kind of knowledge of the system to know what the right thing to do is. This could be abstracted away a little bit. Like Ruby on Rails has the concept of like the controllers for this module or whatever it's called, like all of these controllers can have some common access rules, which does make sense, right? Like everything here, here's my logic that does the authorization checks. Like if it's a GET request, I'll do this. If it's a POST request, I'll do that. And you can write that function kind of in one spot with the promise from the toolkit that every one of these controllers will be bound by that authorization function that you wrote. That's good. I mean, it means you only have to write it kind of once per module or something like that. If you don't have that more common functionality, well, it's not hard. Every controller or whatever you call that logic should start with that kind of stanza that says, okay, I'm going to find the thing as long as it's owned by the right person or it's in the right category or whatever. It's also easy to audit, right? I can skim down another developer's code in seconds and say, well, does this controller? Yeah, does this controller? Does this controller? Oh, wait. Oh. And sometimes it's my understanding, sometimes it's theirs. They're like, oh, wait, this is something that should be publicly visible, but this is not. So, okay, that is right, or whatever. Really easy to check. Sometimes you do need a second set of eyes just to make sure it's been done like as universally as it should be. I find this is it's easy to sort of remember it in the big places and forget it in the small places. Like some kind of like Ajax request, like request with some JavaScript code back to the server that says, I would like this extra little bit of information. It's very easy to think like, oh, this request only comes from my JavaScript code. The only way to get the JavaScript code is to be on that page. And then the JavaScript code will do whatever it does, and then it will make the request back to the server for that piece of information. Okay, that's the only way you think it's going to happen, but there's no reason to think that that specific piece of code is the only piece of code that could ever make a specific HTTP request. It's the only one you intended. It's not the only one that might ever do it. It's also easy to have kind of a, again, that like smaller piece of information leak out. Like for example, like on courses, like whatever the equivalent URL to that is. And I think there is one somewhere where like if you as a student go looking at your marks, you will see a user ID in that URL. So there is some check there that says if the currently logged in user is ABC12, show them the page, else not. It's really easy to write that as, and let's see if I can, let's see if I can write some pseudocode here for this. So if I have, well, I get that user ID, I get this string ABC12, and I get the course is compute 470 somehow from I parse it out of the URL. Then the thing I don't want to do is so I don't know, like that or something. Or so if they're not logged in, they're not logged in. Easy. And then maybe I say so I go to my ORM and I say, okay, all the mark objects, or of all the mark objects, find the one with course equals this and user ID equals that. If it doesn't exist, it doesn't exist. So now I've leaked information. And the way I've leaked information in logic like this is if somebody else, right? So somebody else in the class says, hey, I wonder what my buddy ABC12 got on the assignment. They don't see it. So that much is correct. The problem here is, I wonder if my buddy ABC12 is in this course. Are they registered or did they drop? And that's a piece of personal information that we're not to disclose. And now the other person, okay, if they can log in, so now they know either their friend got a mark on this assignment or didn't. If they didn't get a mark on the assignment, they get a 404. If they did get a mark on the assignment, they get a 403. They've just learned something that's supposed to be private. They've learned whether or not their friend handed in this assignment, and then can start to say, ooh, maybe they dropped the course. I think it's reasonably safe to do, I guess you can do this in the other order. So yeah, so I can check this first. I can check, did the user ID, is the user ID in the URL the same as the person who's currently logged in? If it's not, then you just say 403 forbidden. No matter whether this person exists, they're maybe not in the course, who cares? If I try to see anyone's mark but my own, 403 forbidden. And then by this point in the logic, I know the user that's in the URL matches the person that's logged in. Now I kind of have some idea who it is, and I'm not too worried about leaking information about the student. Very easy to again, just have that little tiny information leak out just because of the details of your logic, and it's worth keeping in mind. Again, I see it done. Let's put it this way: I wouldn't bet very much money, if it was my own money, that Canvas does this right 100% of the time. I think Courses does it right. It's so subtle to detect. Okay, hour 2. God, it's a good spot for a break, but also an awkward spot for a break. But it's gonna be a break. What am I fussing over? Nobody's going to complain like, oh, our break was 12 minutes today, not 10. Let's take a break. We'll come back to some more of this in a couple of minutes. Yeah, take a break. Go get seconds of your dinner. Get dessert, whatever it is you're doing right now. Go get a beer. I'm not in control of these things. See you in a few minutes.